Hello, class. Today we're going to continue to talk about heat, thermal energy, and temperature. Some of this is going to be a bit of a review for you, and some of it is going to be new information. And so let's go through and we're going to start off with a bit of a review, and then we'll flow into some new info as we're going. So, the first question: what is heat? Heat is the measurement of energy that flows from something with a higher temperature to something with a lower temperature. And so it flows from hot to cold. Cold is not really something, so when you touch something and the feeling of cold comes into your hand, it's really just the heat leaving your hand and going into whatever that object is. And so thermal energy is always flowing from hot to cold, and heat is the measurement of that energy. We talked about temperature. Temperature is the measurement of the average kinetic energy of particles of matter. So, when you stick a thermometer into a glass of water, or if it's just in the air, that those molecules around the thermometer have kinetic energy, and they're moving around and they're bumping into the thermometer, and the thermometer reads that on a temperature scale that it's set up for. And so that average kinetic energy is what the temperature is. So it's not exactly the same as heat, though it is a measurement that we use to tell us how hot something is. But this is average kinetic energy. This part in the red here is really the phrase you're going to need to remember for temperature. Temperature scales, we talked about this on Thursday. Three main temperature scales that we have: Fahrenheit, Celsius, and Kelvin. If we look at Fahrenheit first, it has that freezing point of 32 degrees, boiling point of 112 degrees. Now, this is water that we're looking at here. All of these are going to be measured with water kind of being the baseline for what we're looking at. And so you'll need to know that about Fahrenheit. There's not much more for our class that you need to know about Fahrenheit other than being able to recognize the scale when you see it, and those 2 points really being the reference points for you. We also talked about Celsius. And so you can ignore this first part here. You don't really need to know that. But you do need to know the boiling point and the freezing point for the Celsius scale. It's at 0 for freezing and 100 for boiling. Originally, what this is talking about here is it was the other way around, and then they reversed it. And so I apologize for leaving that there. The original name was the centigrade, and so you see it's 1 to 100, and so like a centimeter measures its 100th of a meter. That meter stick has 100 centimeters on it. The Celsius scale or the centigrade scale had 100 markings on it. And so you're going to need to know this scale. This is the scale we're going to use in science class. Everything's going to be on the Celsius scale. And then we talked about the Kelvin scale. This scale is based on the temperature at which all molecular movement stops, known as absolute zero. And so they invented a scale where 0 Kelvin is absolute zero. The freezing point of water is 273, and the boiling point is 373. And so to convert from Celsius to Kelvin, you're basically just going to add or subtract 273. And so make sure you have that down. If you're going from Celsius to Kelvin, you're going to add 273. If you're going from Kelvin to Celsius, you're going to subtract 273. And so that's all you have to do to go back and forth. You will need to be able to make those calculations, but it's just a matter of adding or subtracting 273. Some other important information or important facts when it comes to heat that we talked about on Thursday. One, it'll take more thermal energy to raise the temperature of a larger amount of water than it will for a smaller amount of water. So a lake is going to take much more thermal energy to raise the temperature than a glass of water is, or a pot of water that you may have on the stove. And so you need to know that they may have the same amount of thermal energy, but the larger bottle of water is going to be a lower temperature because of it. Temperature does not change during a phase change. So we looked at this on Thursday with the lab that we did. The thermal energy is being used to break the bonds of the substance until the phase is completely changed. And so we have an example of a phase change diagram here. You're going to need to be able to identify this, write these down, know what this looks like, know what pieces go where for future tests and quizzes. So make sure that if you didn't get this down and didn't write this down on Thursday, that you take the time to draw it and write it down now. But you can see as heat energy is being increased along this line, the temperature is going up. When it hits a phase change, it flattens out. The temperature stays the same, though heat energy is continuing to be added. And then it becomes a liquid, goes up, hits another phase change, and levels out until it completely changes phases. So right now I want you to pause the video, and there's an article on Classroom there with this assignment from CK12, Thermal Energy. You can also go to this site if you want to just pause it and type it in. And read the information about thermal energy. And then there's information on your packet to fill in and answer questions about that reading. So go ahead, pause it, go over to CK12, read the article, and then come back to the video to finish. All right, so now we're going to talk about conduction, convection, and radiation. You like my mug there? Conduction, convection, and radiation. We see in this picture of the boiling pot of water, we have all of these things going on at the same time. So let's talk about what these things are. There's three ways that thermal energy can be transferred. Conduction, which you see right here as the handle of the pan gets hot, then the conduction, heat's being conducted to the hand of the person. We also have convection, which is in here, these molecules moving around in the water. And then radiation. Radiation is coming up off of the stovetop. And notice this pot is being held above the stove. And so that radiation radiating off of that into it. That's going to be important as we look at these. It's not touching in this picture. So let's look at conduction first. Conduction is the movement of heat through direct contact. So this is the key phrase, direct contact. Now you see in this spoon is in the hot water and heat is moving up the spoon because it's directly in contact with the hot water. That's the direct contact. So in our previous picture that we looked at, had we had that pot sitting on the stove, that would have been conduction. So anything direct contact is going to be conduction. Some examples of conduction is touching a metal spoon in a cup of hot liquid, which we just saw in that picture. Putting a heating pad on your back. If you've ever gotten hurt and you put a heating pad on your back to be able to help relax, that would be conduction. It's moving directly from the heating pad to your skin. Feeling the heat from a hot poker in a fireplace. And so if you use a fireplace at home and you have the poker there in the fire and grab it, it's going to be hot. That would be conduction. And then placing a hand on top of a basket of hot rolls. And so anything that's warm and you make direct contact with it, it's going to be conduction. Again, direct contact is the key. So then it looks at convection. Convection is going to be the transfer of thermal energy through a fluid. Now, a fluid, for our purposes, can be a gas or a liquid. And so you see as this heat begins to travel up, the cold air is forced down, begins to heat up by what's down here. Maybe it's a stovetop or something. And then that water moves back up. And so when you see water boiling, that's what's going on as those bubbles pop up to the top as it's moving. So right here, even if it's in direct contact, would be conduction, but inside where the liquid is convection. It's also how our air moves around just in our environment, in our atmosphere, is through convection. Moves up and down due to the differences in density. As it heats up and those molecules begin to spread apart, it becomes less dense and rises to the top, where it cools and then sinks back down to the bottom. Hot fluid rises, cold fluid sinks. Some examples of convection. macaroni rising and falling in a pot of boiling water. If you've ever made macaroni, that it's all kind of sitting on the bottom and then it starts to move to the top and kind of move around. A lava lamp rising and sinking. It has the lamp that's in the base that heats up the oil inside the lamp, causes it to rise to the top. As it cools off, it sinks back down. Hot air rising in the atmosphere, cold sinking. And then hot water rising in the ocean and cold water sinking down to the bottom. Um, and lastly, let's look at radiation. Radiation is energy transmitted in waves or a stream of particles. And so you see the sun sends light rays to the earth, which have thermal energy in them, heating the earth. And so, as you are standing across the room, maybe from a heater, if it's not blowing air, that's going to be radiation that's causing it to come from that object over to where you are. It travels through space and other types of matter. Um, and so, radiation doesn't need direct contact. It can move across space or across a room. And it doesn't necessarily have to do with air moving or water moving. It's just the heat that's coming off of it. So when you talk about a radiator heater, that's what it's doing. It's radiating that heat into the room. Some examples of radiation: laying out in the sun on the beach, feeling that warmth is going to be radiation. Holding your hand over a burning match without touching it. And so if you're close to a fire, then you're going to feel that. The warmth of a bonfire is going to be the same thing. That's going to be radiation coming off. Holding your hands over or near a light bulb is going to be radiation. Most often, you're going to notice all of these have to do with light. And so if there's light, then you're going to have radiant waves coming to you, producing heat. So looking at this picture, can you demonstrate a way to explain thermal energy transfers using this picture? And then can you define conduction, convection, and radiation? And give some examples of each one. Now I want you to go ahead and pause the video again and to go to this website. This is also going to be linked on Google Classroom. Use the simulator and kind of play around with that online simulator to become familiar with the different types of heat transfer. Make sure you're asking questions. If you have questions at this point, there's a place in your notes to illustrate an example of each type of energy transfer. After you've illustrated the example, there's an assessment that's there, the very back page, for you to be able to complete and turn that in. Feel free to ask questions. If you don't understand, make sure you're getting a concept of what each one of these things are before you do the assessment, or even while you're doing the assessment, to get an idea of each one of these types of transfer. We're going to be doing a lab this week, where you'll be making s'mores using each of these different types. And so we'll have some fun with it, learn some more information about it, and be able to apply that to our daily lives. Well, class, go ahead, finish up the assignment and ask questions along the way. Turn in that assessment when you get done with that.